Hello 12th grade. Today I'm going to go over with you one of the applications of calculus, and chances are this kind of problem will come out in your paper 1 or paper 2 test. After I have explained to you the problem, I will, at the end of this presentation, there is a problem that was given in year 2009. Okay, so let's go over with the problem. Say you are given a function of x, and you can see it here on the top. Okay, and then you're asked to find the local extrema, and then you have to identify the local maximum and the local minimum, and then at the end you're asked to find the coordinates of the maximum and minimum function of the interval in the intervals 0 to 30. Okay, so the first thing that you need to do is that given this function, first thing you do is to differentiate or find the first derivative. Okay, suppose you're able to see this, okay, and figure this out because you'll see this symbol, and that symbol means that you're going to get the first derivative. Okay, so from x cubed you get 3x squared, and then from 45x squared or negative 45x squared it will become negative 90x plus then 600x. The first derivative of that one is 600, and then you don't have to write the constant 20 anymore because one of the laws of differentiating is that if you have a constant it becomes 0. Okay, after you get the first derivative of your function, you set it to 0, and when you do, it means that you are setting its gradient to 0, and then if you graph it, suppose at that time you will have a horizontal line. So here's your 0, okay, and then your first derivative. The next, to solve for x, what you need is to factor. And 12th grade, we spent a lot of time for you to be able to practice how to factor, because it's really important that you can factor, or else you won't be able to find the value of x. Okay, so when you factor this polynomial expression x squared minus 30x plus 200, you may use the sum and product, strategy of sum and product, or splitting the middle term. Okay, so by then when you use that strategies, you will get to x minus 10 times x minus 20 over here. Okay. Setting both binomials to 0, then you will have x is equal to 10 and x is equal to 20. Okay, I don't have to write everything out. I hope that what you can do though is that at home or in your place you can get a pen and paper, and then you solve it, and suppose you should get x is equal to 10 and x is equal to 0. Okay, now once you know that those are your local extrema, x 10 and 20, now you need to figure out whether your function at 10 and 20 are either increasing or decreasing. So let's try 10 first, okay? For your extreme at 10, okay, at this point, what you need to do is that, because, okay, let me get a pen. When you had your 10, you set it to 0, so by then you're saying that at x10 your gradient is equal to 0. Okay, and that means that you have a horizontal line over there. Okay, so this is for 10. Now find any value below 10. Okay, the easier one will be the next value, the next number, which is 9. Okay, and then you just use 9 and replace the function the first derivative that you got, which is 3x squared minus 90x plus 600. So replace all your x by 9. You can actually use any number less than 10, but I think it makes more sense if you use 9. Okay, so after you replace 9 to all of the x's, okay, you'll get the value 33. Okay, since the value 33 is positive, okay, that means that your function here, because it has a gradient, a positive gradient, it means that your function is increasing and going up as its direction. Okay, now because you're using the extrema x is equal to 10 when you set it to 0, the next thing that you want to do is that after finding a value that is lower than 10, you need to find a value that is greater than 10. And the next value that is greater than 10 is 11. Okay, so then use 11 to replace your x, using again the first derivative of your function. So replace 11 to all of your x's so that you will get 3 times 11 cubed minus 90 times 11 plus 600. It will give you negative 27. This means that the gradient is negative, and when the gradient is negative, it means that your function is decreasing. Okay. Now, if I'm going to draw that, if at when x is 10, the gradient is 0, that means it leveled off. Okay, I don't think I can draw a straight line. This is 10. Okay, you're looking at the side. When the value of x is less than 10 and 9, it says that the function is increasing. So it should be like this. Okay, when you get to 10, okay, it levels off, and then when you use 11 over here, it starts to decrease. Okay, so that means that at x, you are now looking at this. At x, this is to interpret what you just did. Okay, you must have it as your local maximum. At 10, you are at the maximum level. Okay, because you came from an increasing function going up, and when you get to 10, you start going down. So this is your maximum at 10. Okay, so now you found your local maximum. Now, I need to change my pen to pointer. Okay, so by then, to get to the next one, okay, to get the explanation for 20, okay, remember you have two values of x. One is 10 and one is 20. Okay, so then once again, when you found 20, I'm going to change my pen now, and I'm going to use red. Okay. Okay, so at 20 again, your gradient is equal to 0. Okay, that's when you found 20. Now that means that it's in horizontal line. Okay, again, use a value that is lower than 20, and then use that value to replace all of your x's. So it makes sense to use 19 here, so I use 19 and then replace all the x's. So then 3 times 19 squared minus 90 times 19 plus 600, it gives you negative 27. Okay, now negative gradient means that your function is in a decreasing mode. So that means that the line is going down. Okay, now because you're at x20, the next thing that you will do is find out or get a value that is bigger than 20 or greater than 20. So we'll use 21. It's the next number greater than 20. Okay, we replace 21 to all of the x's of your first derivative. Okay, and you will get, in the end, you get 33, which is a positive number, a positive value. That means your slope or gradient is positive. When it's positive, it means that your function is increasing. Okay, I'm going to draw it again. at 20, you are here at 20, when your x is 20, okay, my god, this is difficult to write. I need a pen. I mean, okay. Now, so at the value less than 20, you are decreasing. Okay, so that means that I will be from here, okay, going to 20, okay, and then from there it says after 20 go 21, and it should be increasing. Okay, so then that means that your 20 is over here. That means that 20 is your minimum. So to interpret it again, when your x is 20, that means that 20 is your local minimum. It's the lowest in your function. Okay, as you can see here at 20, you are leveling off. After 20 going to 21, you're increasing again. So the minimum value is at 20. Okay, I hope you understand this. I'm going to change again to my pointer so I can move to the next slide. Okay, so the next slide, you finish letter A, the first question. You found the local minimum and maximum values. Okay, now the next thing is to find the endpoints. X is 0 and then x is equal to 30. Because you only wanted to find the endpoints, what you really want to do is find the y of 0 and 30. You do not want to use the derivative anymore. You would like to use the original function that was given to you. I can go back and read the problem again. Okay, so here we go. To find the endpoint, I don't want to move this. To find the endpoint, I just use this. Okay, so then going back, use it, replace all your x's with 0. Okay, and then you will get its corresponding y, which is 20, and then use x as 30. Use 30 as x, replace all the x's of the original function, and your y now is 4,520. So you rewrite it. Absolute maximum of the function occurs at 30. When your x is 30, the y is 4,520. And the absolute minimum occurs at 0. When x is 0, your y is 20. Okay? I hope you understand. If anything, if you don't, you can always chat with me, because the next question, the next slide is that I'm going to give to you a problem that was given in the year 2009. It's a paper 2 problem, and it's actually worth 6, 7, 13, 17 points. Okay, I would like you to solve this weekend, and then hopefully you get it, and I really want you to work really hard. If there's anything, you can view or watch this video or screencast over and over again until you understand what I have explained to you. If not, you can email me, but what I would really like you to do is try very hard to solve this. This is a mixture of all of the topics that we discussed in the classroom. It asks you to write down the expression for first derivative, okay, and then it also asks you for value c, and your c is missing over here, but you have a point here, okay, given x1 and then y4. Okay, oops. Okay, and here's what we discussed: local minimum, okay, and then finding the coordinates of q, okay, and then set the value which the function is decreasing. We discussed this, okay, and then given a gradient, find the equation. Okay, good luck everyone, and I hope you are able to solve this problem. Okay, bye.